The next time the moon is out, look up at it and notice something you have been not noticing your whole life. You are seeing the same face you saw when you were 6. The same face your grandmother saw. The same face that hung over every person who has ever lived and died on this planet. Every single one of them, all the way back. The same craters, the same gray seas, the same patient expression. The moon has a front, and it has only ever shown us the front. Keep that face in view for a moment, because the longer you look at it, the less it behaves like scenery. For now, I want to tell you something that took me an embarrassingly long time to actually let land, which is that the moon should not be there. Not like that. Not that big. Here's the number that gives it away. The moon is about 3,500 kilometers across, roughly a quarter of the width of the Earth. Picture Earth as a dinner plate, and the moon is not a grain of rice sitting politely beside it. It's more like somebody parked a saucer next to the plate and then insisted this was normal table setting. By mass, it's about 1 part in 81 of the Earth. Call it a bit over 1%. And that, it turns out, is a genuine freak of nature. Because no other rocky planet has anything remotely like it. Look around the neighborhood. Mercury. No moon. Venus. Nothing. Not a pebble. Mars has 2. And I want you to hold the word moon loosely here. 2 little captured potatoes, lumps of dark rock, one about 22 kilometers long, and the other not even 13. The kind of thing you'd call an asteroid if it weren't unlucky enough to be orbiting a planet. That's the rocky worlds. That's the whole set. 3 of them have nothing or next to nothing. And then there's us, hauling around a companion a quarter of our own width, like a small planet got added to the bill by mistake. And before you reach for the giant planets, yes, the giants have famous big moons. But next to their planets, those moons are basically lint on a coat. Ganymede is about 1/12,000th of Jupiter. Titan, Saturn's giant, is about 1 part in 4,000 of Saturn. Our moon is 1 in 81. That is still a planet and a moon, to be clear. The balance point is inside Earth. We are not secretly Pluto and Charon in a trench coat. But by mass ratio, the Earth-Moon system is weirdly pair-like. Too top-heavy. Too intimate. Too much moon. So here is the old question, and it is nastier than it looks. Why does Earth, alone among the rocky planets, carry this enormous, improbable moon? Where did a thing like that even come from? And why does the same face that feels so settled, so companionable, begin to look less like a decoration the moment you measure it? Because measurement is the rude friend in this story. It does not care that the moon looks serene. It keeps tapping the glass and pointing at the numbers. A quarter of Earth's width. 1 part in 81 of Earth's mass. No match among Mercury, Venus, or Mars. No proportional match among the giants either. At some point, nice companion stops being an explanation and starts sounding like the thing you say when you do not want to look too closely at the scene. Fine, let's look closely. Take the face you've known forever and put it under a lamp, the way a detective puts a strange object in a clear plastic bag. Same gray seas, same craters, same expression. And the question becomes very simple. What kind of event leaves a planet with a second face in the sky? One quick thing before we go looking, while that improbable moon is still sitting in your eye. By every number we just took, it has no business being there. Too big, too pear-like, a freak beside three barren neighbors. And yet there it is, the same faithful face every night, having turned up for every human who ever lived without once being asked. If you'd like something else improbable that keeps reliably turning up, there's a new one of these every few nights to be curious at and to fall asleep to. That is the whole modest job of the subscribe button. The moon manages its showing up unprompted. You only have to press the thing once. Right, where were we? A planet wearing a second face, and the simple, nasty question of what could possibly have left it there. To answer that, we have to go back to the worst day the Earth ever had. About 4.5 billion years ago, the Earth was young, and it was not alone in its orbit. The early solar system was not the tidy clockwork you see in a textbook. It was a shooting gallery, a debris yard of rock and dust clumping into worlds, a construction site where the bricks were also the wrecking balls. One of those forming worlds, the one that matters here, has a name. Astronomers call it Theia. I love the name, and I'll tell you why in a moment. But first, I'll tell you what it was. A whole protoplanet, a world in progress, crossing paths with the world that would become ours. Not an asteroid, not a comet, a planet-sized problem. And one day, the two of them met. Now, when I say hit, I want to kill the cartoon in your head, the one where two billiard balls click and bounce. That is not what this was. This was a planet-scale impact, and the energy of it is genuinely difficult to hold in the mind. The impact turned the surface of Earth into a global ocean of liquid rock, a magma ocean, the whole planet, and it ran hot. By some models, somewhere around 6,500, 7,000 Kelvin. Sit with that. The surface of the sun is about 5,800 Kelvin. For a little while, after the collision, Earth was hotter than the face of the sun. The outer skin of the planet, tens of percent of the entire rocky outside of it, didn't melt. It vaporized. It flashed straight into a glowing fog of rock vapor. And out of that, out of the wreckage, the splash, the ring of vaporized and molten debris flung into orbit around the wounded Earth, the moon pulled itself together. That's the theory. It's called the giant impact hypothesis, and it was proposed independently by two pairs of scientists in the mid-70s, Bill Hartman and Don Davis in 1975, and Al Cameron and William Ward in 1976. Though I should say, because science has a talent for leaving the correct answer in a drawer and then acting surprised when it finds it again. A Harvard geologist named Reginald Daly had floated almost exactly this idea back in 1946. He was right, and early, and the field walked straight past him for nearly 30 years, like a person searching for their glasses while the glasses are already on their face. So now, you're probably picturing the moon slowly gathering over millions of years, the way you'd imagine a planet forming, a long, patient accretion. And here's the first thing that genuinely startled me. It didn't take millions of years.
It barely took any time at all.
The early computer models of this, the work of Robin Canup and others, building on simulations going back to Ida, Canup, and Stewart in 1997, show the debris disk pulling itself into a moon astonishingly fast. The simplest models assemble the thing in about a month. The fuller, more careful ones stretch it out to perhaps 100 years. Either way, think about what that means. A whole world, the entire moon, every cubic kilometer of it, condensing out of a ring of glowing debris in less time than it takes a tree to grow tall. You could have watched it happen. If you could somehow look up from the cooling, ruined Earth through the haze, the moon would have assembled over your lifetime, out of the splash. And it formed close. This is the detail I can't get out of my head. The newborn moon wasn't 250,000 miles away like it is now. It coalesced only about 4 Earth radii out, somewhere around 25,000 kilometers, which is something like 16 times closer than it sits today. It would have loomed. A vast, glowing, molten thing filling a huge swath of the sky, far bigger than the moon you know, hanging right there over a hellscape of cooling lava. That was the first moon. Not serene, not pale. A red-hot disk of wreckage, enormous and low, over a planet that was still on fire. And here's the thing to keep hold of as we go. The first turn of the screw. That calm, gray face you've looked up at your whole life, that's the same object. That's this moon, 4.5 billion years later, cooled down and backed off and gone quiet. The peaceful thing in your sky is the scar. It's the cooled over wound from the single most violent day the Earth has ever lived through. We just happened to be looking at it long after the bleeding stopped. Now that's a wonderful story. A foreign world hits us. The splash becomes the moon. Dramatic, tidy, satisfying. And for a long time, it had one enormous problem. And the problem is so good, so genuinely strange, that I want to walk you right into it. Because it's where this whole thing nearly fell apart. And it's where the moon stops being a story about violence and becomes something much more intimate. When the Apollo astronauts went to the moon, they brought back rock. And scientists did to that rock the things scientists do to everything. They checked its chemical fingerprints. In particular, they looked at oxygen isotopes. Oxygen comes in slightly different weights, and the ratio of those weights is like a postcode. Different bodies in the solar system usually carry different isotope signatures, reliably, measurably, the way different towns have different accents. So they checked the moon rock, fully expecting it to read as part Earth, part Theia, a blend, a mongrel, half the splashed up Earth and half the foreign world that hit us. And instead, the moon rock read as Earth, not similar to Earth. Not mostly Earth. Earth. In 2001, Uwe Vickert and Alex Halliday and their colleagues measured it and found the moon's oxygen isotopes indistinguishable from the Earth's, identical right down to the limit of what the instruments could even detect. Think about what that's telling you. Run a paternity test on the moon, and the result comes back saying the moon is Earth. Same material. Same flesh. The thing in your sky is not a stranger that wandered in and got caught. It is a piece of this planet, splashed off on the worst morning of its life, and never allowed to come home. When you look up at that face, you are looking at a casting taken from the Earth's own molten body. It's us. It's a part of us, hanging out there in the dark, going around and around, 4.5 billion years and counting. And here's the headache. Here's the part that nearly broke the theory, and it's beautiful precisely because the evidence is too good. If a foreign world called Theia really hit us, then a big chunk of the moon, the models say somewhere between 60 and 90% of it, should be made of Theia, not Earth. And Theia, having formed somewhere else, should carry its own oxygen postcode, its own accent. So the moon should be shouting Theia at us. And it isn't. It's whispering Earth. Only Earth. In 2014, Daniel Hurwitz and his team went looking with even finer instruments and did, just barely, find a difference, about 12 parts per million, give or take 3. 12 parts per million. That's not the foreign world they were promised. That's the faintest possible accent on a voice that is otherwise unmistakably ours. This is the bit scientists started calling the isotopic crisis, and you can see why. The single best piece of evidence that the moon is made of Earth is also the thing that should not be true if a foreign planet made it. The fingerprint matches us so closely, it nearly throws out the whole case. The smoking gun is missing. So how do you get out of that? How do you smash a foreign world into the Earth and end up with a moon that's pure Earth? And here I have to be honest with you, because this is live science, and I'm not going to pretend the ribbon is tied neatly around the box. Nobody is completely sure. There are several competing fixes, and they're argued over right now. I'll give you the 2 I find most striking, but keep them on the workbench, not in the trophy case. The first is gorgeous. In 2018, Sarah Stewart and Simon Locke proposed that the impact didn't make a tidy disk at all. It made something they named a synestia. Picture not a ball with a ring around it, but the whole thing vaporized into a vast, spinning, donut-shaped cloud of rock vapor. Earth and Theia melted and mixed and boiled together into one churning structure, glowing at a couple of thousand Kelvin. And out of that, out of one common cloud of vaporized, blended rock, the moon condensed, the way frost condenses out of your breath on a cold morning. Not assembled from chunks. Condensed, out of vapor, from the very same stuff the Earth recondensed from. Same breath, same frost. That's why they'd share a fingerprint. They were never 2 materials. They were one cloud. And then the cloud cleared, and the moon drifted off, and the Earth settled back into a ball, and the synestia, which only lasts a century or 2, was gone, leaving no trace except a daughter, the spitting image of her mother. And the second idea is the one that, frankly, I find hard to say out loud without lowering my voice. Because if Theia really hit us, if a whole world's worth of foreign rock slammed into Earth, then where did Theia go? Some of that material may have joined the moon. Some may have mixed into Earth. And in 2023, a team led by Qian Yuan suggested something extraordinary. That the 2 enormous, continent-sized blobs of strange material we can detect deep in Earth's mantle right now, one under Africa, one under the Pacific, each of them larger than the entire moon, sitting almost 3,000 kilometers down, denser than the rock around them, might be pieces of Theia. The buried remains of the world that hit us. Still inside us. Still down there. Now, do not tattoo Theia under Africa and the Pacific yet. This is the freshest and least settled idea in the whole episode, and the honesty is the whole point. Yuan's team proposed it in 2023. It is one striking interpretation, and the origin of those deep blobs is genuinely, actively debated. Plenty of geologists think there's something else entirely. Churned up ordinary mantle, nothing to do with any impactor. So I'm not telling you it's true. I'm telling you it's on the table. And the table is unsettling enough already. The dead planet that gave us the moon might not have entirely left. 2 pieces of it, each bigger than the moon you can see, might be lodged deep inside Earth right now. Sediment from a 4.5 billion-year-old crash that never quite settled. which makes the name feel a little less like decoration and more like a dare. The geochemist Alex Halliday named the impactor Theia in the year 2000, after the Greek Titan who was the mother of Selene, Selene being the goddess of the moon. So the world we say gave birth to the moon is named after the literal mother of the moon. And one live possibility is that pieces of that mother are still inside Earth. The scientists, it turns out, are romantics with alarming geological follow-through. So that's where the moon came from. A catastrophe, a splash, a casting of the Earth's own body, cooled into the gray disk overhead. But I started us on that face, the one unchanging front the moon shows us, and I haven't told you why it does that. Why one face? Why has the moon never, in all of human history, turned around? Here's the answer, and it's the violence still working, just very slowly. Imagine the young moon not as a hard billiard ball, but as a warm lump of clay on a turning plate. Earth's gravity pulled harder on the near side than the far side, so it stretched that clay into a slight egg shape, raising a bulge aimed roughly at Earth. Then, as the moon spun, Earth's gravity kept catching that bulge a little off-center, the way your fingers would catch a raised lump on a spinning lump of dough. Tug, slow. Tug, slow. Rotation after rotation. The grab became a break. Over a very long time, the break did what breaks do. It stopped the moon's spin, not relative to space, but relative to us. The bulge got locked pointing at Earth, and there it stayed. The moon now turns exactly once for every orbit it makes, every 27 1/3 days, so the same hemisphere faces us forever. Astronomers call it tidal locking, which is the formal name for why the moon has been making the same face at us since before faces existed. So the face overhead isn't just a scar. It's a scar that got frozen pointing at us. The same hemisphere of that ruined, splashed-off piece of Earth has been turned toward this planet, holding still, watching, since before there were eyes to watch it back. Every human who ever lived looked up at the identical face, which means the far side, the back of the moon, was, for almost the entire history of life on Earth, a place no human being had ever once seen. 4 billion years, and the back of that face was a total secret. Until October 7th, 1959. A small Soviet spacecraft called Luna 3 swung around behind the moon, and for 40 minutes, it did something almost unbearably charming for a Cold War robot. It took photographs, 29 of them, on actual film, and then developed that film on board in a tiny automatic darkroom in the belly of the probe, and then radioed the developed pictures back across nearly 500,000 kilometers of empty space to Earth. Grainy, ghostly, half-ruined images. And on them, for the first time, any human being saw the back of the moon's head. 4 billion years of a hidden face, and we finally peeked around it in 1959 with a flying darkroom. I find that almost impossibly moving, that the secret held for the entire age of the planet, and then we just looked. So, the moon is a scar.
It's made of us.
And it's been holding one face toward us since the beginning. That's what it is. Now I want to show you something almost funnier, which is how long it took us, how badly the cleverest people who ever lived fumbled it to figure out where this thing came from. Because the right answer, the splash, was very nearly the last answer we tried. For a long time, the moon was simply there, a given, a lamp hung in the sky. The first person in this story to come at it with real physics, equations, angular momentum, the actual mechanics, was, of all people, a Darwin. Not Charles, his son, George Darwin, an astronomer. And in 1879, he proposed the first serious scientific theory of the moon's origin, and it was a beauty. George Darwin's idea was this. The young Earth was molten and spinning fast, really fast, and a fast-spinning blob of liquid bulges out at its equator. Spin it fast enough, he reasoned, and that bulge could become unstable, and a great gob of the Earth could simply fly off, flung out by the rotation, and settle into orbit as the moon. The moon, in this telling, is a piece of the Earth that the Earth threw, not knocked off by an impact, but spun off under its own steam. It's called the fission theory, and you can see the appeal. It neatly explains why the moon would be made of Earth stuff. Because it is Earth stuff. It came right out of us. And this is where the folk imagination ran with it, because there's an irresistible version of this story. If the moon flew out of the Earth, then surely it left a hole, a scar. And around 1881 or 1882, the records are fuzzy on exactly when. A clergyman and geologist named the Reverend Osmond Fisher, writing in his book on the Earth's crust, looked at the globe and pointed at the single biggest dent on it. The Pacific Ocean. There, he said. That vast basin, that enormous gouge in the face of the Earth, that's the hole the moon left when it tore away. The Pacific is the moon's scar. I love this so much because it's gloriously wrong and also half right in a way Fisher couldn't have known. It's wrong. The floor of the Pacific is, chemically, nothing like moon rock. And worse, the Pacific Basin is only about 200 million years old. The seafloor recycles itself through plate tectonics, whereas the moon is billions of years old. The moon is 20 times older than the hole it supposedly came out of. The timing alone kills it dead. But the instinct that the moon is a piece torn out of the Earth, that you might find its absence written on the planet, that instinct was reaching towards something true. The moon is a piece of us. Fisher just had the wrong piece and the wrong mechanism and pointed at the wrong hole. And the fission theory itself? It died on arithmetic. To spin a gob of itself off, the proto-Earth would have to have been whirling around absurdly fast, a full day in about 2.5 hours. Faster than a long lunch. And here's the catch. A system that spun that fast would have a colossal amount of angular momentum, 3 or 4 times more than the Earth and Moon actually have between them today. And angular momentum doesn't just vanish. You can't lose it. So if fission were true, that spin would still be in the books, and it simply isn't. In 1930, the geophysicist Harold Jeffreys, who had himself once been sympathetic to the idea, drove the final nail in. He showed that the friction of that very bulge would have braked the Earth's spin before it could ever fling a moon off. The thing that was supposed to launch the moon would have stopped the launch. Fission was finished. So, if the Earth didn't throw the moon, maybe it caught it. That's the next theory, and it's the one most people, if you ask them cold, will guess. The moon formed somewhere else, somewhere out in the solar system, a finished and independent world. And one day, it wandered too close to the Earth, and the Earth's gravity reached out and snared it, lassoed it into orbit. A captured moon. In the early 1950s, the chemist Harold Urey took this idea seriously in his book, The Planets. and Horst Gerstenkorn worked on the dynamics of it in 1955. It's a tempting picture. It would explain why the moon is so different from the Earth in some ways. And it falls apart for a reason that is just lovely physics. Capturing a whole world is incredibly hard, far harder than people imagine. Think about trying to catch a bowling ball that's rolling past you at full speed. If you just stick your hands out, it doesn't stop. It blows straight past, or it knocks you over and keeps going. To actually capture it, you have to bleed off all that energy of motion somewhere into something. And a moon-sized body screaming past the Earth has an enormous amount of that energy.
There's nothing to dump it into.
Unless the Earth were swimming in a thick cloud of gas to provide drag, friction to slow the intruder down, a passing moon just slingshots around and carries on into the dark. And by the time the Earth and moon were around, that gas was long gone, blown away within a few million years of the sun igniting. So, no brakes. No capture. The bowling ball blows past. And there was a second problem with capture, which is the one we already know. Even if you could somehow snare a passing world, why would that random foreign world have the Earth's exact oxygen fingerprint? A moon born somewhere else should read as somewhere else. It reads as home. Capture can't explain that any more than fission could explain the missing spin. So the Earth didn't throw the moon, and the Earth didn't catch the moon. Third option, and it's the sensible-sounding one, the one that feels like it ought to be right. Maybe they were just born together. Out of the same swirling cloud of dust and rock that became the Earth, a second, smaller clump gathered alongside it, at the same time, in the same place, from the same material. The Earth and the Moon as twins, a double planet, forming side by side. It's called co-accretion, and the idea goes all the way back to Edouard Roche in the 19th century. And it has the great virtue of explaining the isotopes for free. Of course the moon reads as Earth. They were made from the same batch. And it breaks on a single number. And the number is iron. The Earth is dense, about 5.5 grams per cubic centimeter. And it's dense because it has a great heavy core of iron sitting at its heart. The moon is not dense. It comes in at about 3.3. It's feather light by comparison because it has almost no iron core to speak of, barely any. Now, think about that. If the Earth and the moon condensed out of the same cloud, in the same place, at the same time, from the same stuff, they should have grabbed the same share of iron. They should be made of the same proportions of everything. But the Earth is rich with iron, and the moon is starved of it. A shared birth from a shared cloud simply cannot produce one body loaded with iron and another body right next to it that somehow skipped the iron course entirely. The twins don't match, so they weren't twins. And here is what I find genuinely wonderful about this whole act. Look at what each of these three theories got wrong, and how. Fission failed on angular momentum. The spin's not there. Capture failed on dynamics and on the isotopes. You can't catch it. And a stranger wouldn't be made of us. Co-accretion failed on the iron. Twins should match, and these two don't. 3 theories. 3 completely different fatal flaws. They were, as the writer Dana McKenzie put it in his book on all this, 3 imposters. 3 suspects, each with an alibi that turns out to be a lie, and not one of them is the culprit. And the strange thing, the thing that makes this a real detective story, is that all 3 of them survived, argued over and unresolved, right up until we actually went to the moon and brought the rocks home. The rocks were the fingerprint that matched none of the three. And I have to tell you about Harold Urey, because his story is the most human thing in this whole episode, and it has a kind of grace to it. Urey, the capture man, had a very particular and very deep conviction about the moon. He believed it was cold, that it had never been molten, never melted, that it was a pristine, primordial leftover from the birth of the solar system, a thing that had been sitting in the deep freeze since the beginning, untouched, unchanged. He called it, in effect, a Rosetta Stone, a cold record of the early solar system, frozen at the moment of creation. That's why he liked Capture, a cold, finished, never-melted moon, formed elsewhere and snagged. And he wanted, more than almost anything, for us to go there and read that frozen record. And in October of 1958, the 29th, at a colloquium at the Jet Propulsion Laboratory, Urey stood up and said something I think about a lot. He predicted, out loud, in front of his colleagues, that the new data coming from the moon might give him, in his words, a very red face. He said, and I'm quoting the man, "Nature can always be more complicated than we imagine." He said it about himself. He stood up and told a room full of scientists that the thing he'd staked his reputation on might be about to be proven wrong, and that he'd wear the blush if it was. And he was wrong. That's the thing. When the Apollo rocks came back, the moon turned out to be exactly what Urey insisted it wasn't. It had been molten. It had ancient volcanoes, seas of frozen lava. Those dark gray patches you can see on the face up there, those are Maria, old lava flows. The moon was not a cold, pristine Rosetta Stone. It was a once melted, violent, processed world. The red face Urey foresaw, he got. But look at the size of the man in that prediction. To stand up before the evidence and say out loud, I might be the fool here. Nature is cleverer than I am. That's not the embarrassing part of science. That's the best of it. So by the time the Apollo rocks were back and analyzed, the field was a mess. 3 classical theories, all of them with fatal wounds, none of them able to explain the rocks. And the new impact idea, the Hartman and Davis splash, sitting off to one side, still not taken entirely seriously. Everyone had a camp. Nobody could win. It was less a settled science than a dinner table where every guest has a different suspect, and every suspect has somehow already been cleared. And then, in October 1984, a remarkable thing happened. A conference was called in Kona on the Big Island of Hawaii, specifically and only to settle the question of where the moon came from. Imagine renting a conference room, filling it with slide projectors, coffee cups, lunar rocks, and people who have spent their careers disagreeing politely in print, and then saying, "All right, everybody, no one leaves until the moon has a birth certificate." The organizers, Bill Hartman among them, essentially dared the field to decide. One of them put it that the community had about 18 months to make up its mind. So the scientists came with all their theories and all their isotope ratios and argued it out. And one participant described the before and after of that meeting in a way that gives me chills. Before Kona, he said, there were 3 camps: fission, capture, co-accretion, the old 3. After Kona, there were only 2 camps left: the giant impact camp and the agnostics. That's it. One conference later, the suspect list had basically been crossed out with a red pen. Because the giant impact was the only story that could bring the main clues into one room. The The size, the orbit, the missing iron core, the angular momentum, and the unnerving Earth-like chemistry of the rocks, even if that last clue still came with the isotope headache we just met. The three imposters each explained one clue and then tripped over the next one. The impact explained the crime scene better than anything else on the board. So now we know what the moon is, and we know how hard it was to figure out. It's the splashed off, cooled over, iron poor scar of a planet-scale collision made largely of Earth's own body, locked face first toward us, drifting in the dark. Which leaves the last and best question. This violent thing, this wound, what does it actually do for us? Because the answer is, it has been tugging on your world in ways you almost never have to notice. And it is, just as quietly, leaving. Here's a thing you have never had to think about, because the moon has been doing the boring admin for you your whole life. The tilt of the Earth. Picture the Earth as a spinning top with a pencil stuck through it at a slant. That slant is about 23 degrees off vertical, and it is the entire reason you have seasons. Lean toward the sun, summer. Lean away, winter. Simple enough. But a spinning top does not keep its pencil perfectly still forever. It wobbles. It nods. Left alone long enough, it starts acting like it has had one drink too many. With the moon, Earth's wobble is tiny. The tilt drifts only about 1 1/3 degrees either side of 23. That is the quiet miracle. The seasons do not have to reinvent themselves every few million years. Summer stays recognizably summer. Winter keeps its job description. The whole climate system gets to work from a familiar calendar instead of a roulette wheel. And in 1993, a French astronomer named Jacques Lescar, working with Joutel and Robutel, published the horror movie version of what might happen if you take the moon away. His calculations said a moonless Earth's axis could swing wildly, anywhere from 0 to more than 85 degrees, tumbling and lurching over millions of years. 85 degrees means the planet is practically on its side. The poles roast. The equator freezes. The climate stops behaving like climate and starts behaving like someone is shaking the snow globe. In Lascar's picture, the moon is the great stabilizer, the heavy hand near the spinning top, keeping the wobble from becoming a disaster. That's the popular version of the story, and you can see why people like it. Without the moon, no stable seasons, maybe no complex life. Very clean. Very dramatic. Excellent trailer. So now, the scar wears a stranger shape. The wound from the worst day has cooled into a keystone. You know, the wedge-shaped stone at the very top of a stone arch, the one that everything else leans on, the one that holds the whole curve up. Pull the keystone, and the arch collapses. The moon, with this much mass and this orbit, may be the keystone of the seasons, the stone the whole arch of our stable climate is leaning on. The violence became the thing that holds us steady. But, and this is where the universe does the annoying thing where the dramatic story has a footnote. That 0 to 85 degrees chaos without the moon claim has been seriously challenged. In 2012, Jack Lissauer, Rory Barnes, and John Chambers re-ran the moonless Earth with newer methods, and their version was much less apocalyptic. In their simulations, a moonless Earth's tilt typically wandered only about 10 degrees or so. Some runs more, 10 to 25, but nothing like the full 0 to 85 disaster cut. Lissauer said the lunar effect was, in his words, just minor things. Barnes put it even more bluntly. I don't think there would be any dire consequences to not having a moon. And even earlier, in 1997, Williams and Casting had modeled wildly tilted Earth-like worlds and found that even a planet lurching through big tilt swings could stay habitable. A thick atmosphere smooths the extremes out, the way a heavy blanket smooths the shape of whatever is underneath it. So, which is it? Is the moon the keystone holding up the whole arch, or is it more like a very useful bit of trim? Helpful, steadying, but not the stone everything depends on? The honest answer today is, we're not sure. Mars is the warning label. With only its 2 captured pebbles for moons, Mars really has tumbled chaotically, its tilt wandering from near 0 to more than 60 degrees over millions of years. Sloshing its ice caps from pole to pole, Tuma and Wisdom showed that back in 1993. So the danger is real. But whether Earth would truly fall into that kind of chaos without its moon, or just wobble harder and keep going, that is still argued over. And I like that uncertainty here. It makes the moon less like a magic amulet and more like an actual object in an actual universe. Helpful, maybe crucial, maybe not as crucial as the dramatic version says. The scar may be a keystone, or it may be a brace. Either way, it has been leaning into our seasons for a very long time. And the awkward part is that the brace is not bolted in place. But there's one gift the moon gives that nobody argues about, and you can watch it happen at any coastline on Earth. The tides. The moon's gravity pulls on Earth's oceans, heaping the water up into a bulge on the side facing the moon, and, by a quirk of orbital mechanics, a second bulge on the far side too. As Earth turns under those bulges, the sea rises and falls around the coasts, the great breathing of the oceans. The moon raises the dominant tide. That much is simple and certain. Here's the lovely counterintuitive part though, the part that trips everyone up. The sun is also out there, and the sun is about 27 million times more massive than the moon. So why doesn't the sun boss the oceans around? Why is the little gray rock in charge of the shoreline, while the star sits there with 27 million times the muscle? Because tides are not a normal strength contest. In tide world, distance gets 3 votes. Tidal force falls off with the cube of distance, distance multiplied by itself and then by itself again, because apparently one layer of inconvenience was not enough. The moon is about 390 times closer to us than the sun. Count that closeness 3 times over, and you get roughly 59 million. So the sun walks in with 27 million times the mass, very impressive, lovely resume, and still loses the meeting? The solar tide is real, about 46% as strong, which is why tides get extra high when sun and moon line up, but the moon wins.
Closeness beats mass.
The little dead rock beats the star. But now watch what those tides cost, because this is the turn, and it's the heart of the whole thing. Those tidal bulges in the ocean don't sit perfectly under the moon. The spinning Earth drags them slightly ahead, like a blanket caught on a turning wheel. That lopsided heap of water pulls back on the moon, and it also acts as a brake on the Earth's spin. Friction. Every tide, every day, the ocean is very gently putting its hand on the spinning planet and saying, slower. And here's the astonishing part. The spin the Earth loses doesn't vanish. It gets handed to the moon, fed into the moon's orbit, and a body that gets fed orbital energy climbs to a higher orbit. It moves away. Do you see what that means? The same mechanism that gives us the tides is in the same motion, pushing the moon away from us. The gift has a receipt stapled to it. The thing that steadies the rhythm is paying for that rhythm by leaving. It's a metronome that winches itself a little farther from us with every single beat. And we can measure both ends of it. Just after the moon formed, a day on Earth was only about 5 hours long. 5. Tidal breaking has been stretching it out ever since, adding roughly 18 hours to get us to the 24 we have now. It's still happening. The day is getting longer by about 1 3/4 milliseconds every century. Slow enough to be ridiculous. Real enough to show up in ancient eclipse records going back to 700 BC, as Richard Stevenson and his colleagues measured. And the most beautiful proof of all of this is written in a rock in South Australia. There are formations there, tidal rhythmites, layers of mud laid down by tides about 620 million years ago and frozen into stone. And you can count them the way you'd count tree rings. And when the geologist George Williams read that ancient calendar, here's what it told him. 620 million years ago, a year on Earth was about 400 days long. Not 365. 400. There were about 13.1 lunar months in a year instead of 12. And a single day, sunrise to sunrise, lasted only about 21.9 hours. Sit with that. Not a different kind of year, but a year chopped into more shorter days. Earth was spinning faster back then, and the moon was closer, and you can read all of it in the stripes of a 600 million year old mudstone. A calendar from a vanished world telling you the days have been getting longer and the moon has been backing away the whole time, written down in stone long before anything could write. And while we're being honest about what the moon really is, let me strip one more bit of romance off it, because it earns the romance back later. We talk about moonlight as if the moon glows. It doesn't. The moon is dark. Its surface reflects only about 12% of the light that hits it. It's albedo, that's called, which means the moon is, as a material, about the color of worn asphalt. Old coal. A dark gray rock. Moonlight is just sunlight bouncing off a dark rock, and it looks bright to us for one reason and one reason only, because the moon is close, and it's fully lit, and there's nothing else up there. That faithful lamp in the sky isn't a lamp at all. It's a feeble, dark, dead thing. A nightlight running on borrowed light, the color of a wet road. And it only seems to shine because it happens, for now, to be near. For now. Because here's the last gift, and it's the one that turns everything. Of all the things the moon does, there is one that is so improbable, so cleanly staged, that it is almost impossible not to read it as a trick set up for our benefit. The total solar eclipse. When the geometry is just right, the disk of the moon slides over the disk of the sun and almost perfectly fits it, blotting out the blazing face and leaving only the ghostly silver corona streaming around the edge. It looks less like astronomy and more like the sky briefly closing one eye. And it happens because of a coincidence so clean, it feels rigged. The sun is about 400 times wider than the moon. The sun is also about 400 times farther away. Those two enormous numbers, 400 and 400, nearly cancel out, so that from the surface of Earth, the sun and the moon both appear about half a degree wide. There is no physical reason for that. None. The size of the moon and the distance of the sun have nothing to do with each other. It is a pure, dumb, breathtaking coincidence, and it is the only reason the moon can hide the sun at all. And it is almost completely unique. One survey looked across the moons of the solar system, 141 of them, and Earth came out as essentially the only world with a clean sun-covering eclipse like this. Now, the universe does try to sneak a few technicality cards onto the table. The survey was an amateur one. A couple of Saturn's little moons barely scrape into qualifying, and from Mars you can watch Phobos cross the sun, but it is far too small to cover it. So the careful version is not Earth is the only moon case in the universe. Case closed, everyone go home. The careful version is stranger and better. Among the worlds we know, Earth is essentially the one that gets this particular trick. Of all the places, with all their moons, we're the place where the shadow fits. And here is the turn. Here is the thing that took my breath away the first time it actually sank in. That near-perfect match, 400 and 400, is not permanent because the moon is leaving. Remember the tides winching it outward? The moon is receding from Earth right now, as you listen to this, at about 3.8 centimeters a year, which the scientists who measure it like to describe as roughly the speed your fingernails grow. That slow. And we know it to within a few millimeters because of one of my favorite experiments in all of science. The Apollo astronauts left mirrors on the moon, panels of reflectors sitting in the dust, and observatories on Earth fire laser pulses at them and time how long the light takes to come back. Each pulse sends something like a billion photons at the moon. Of that billion, the number that finds the mirror and makes it home to the telescope is, on average, about 1. 1 photon. We throw a billion grains of light at a mirror on another world. Wait for one obedient little grain to limp home. And from that one grain, we measure the moon drifting away at the speed of a growing fingernail. And because the moon is slowly leaving, its disk in our sky is slowly shrinking. It is getting a little farther and a little smaller every year, which means the perfect eclipse has an expiry date. Run the clock forward, and the moon's disk will become too small to ever cover the sun completely. Total eclipses will end. The astronomer John Meese calculated roughly when this era closes, and the honest answer is a range, not a date. Somewhere in the neighborhood of hundreds of millions of years from now, with different assumptions giving different numbers, from perhaps 600 million to over 1 billion years out. I can't give you a clean number, and I won't pretend to. But the direction is certain. The eclipses are ending. And here's the thing that makes it almost too much. You can already see the ending beginning. Sometimes when the moon is at the far end of its orbit and looks a little smaller than usual, an eclipse comes and the moon doesn't quite cover the sun. It leaves a thin, blazing ring around the edge. People call it a ring of fire, an annular eclipse. And in fact, about 60% of central eclipses are already this kind, because the moon's disk is, on average, about 2% too small to cover the sun. That ring of fire is a preview. It's the closing notice, written in fire around the moon's own edge. Rewind deep enough, and in the standard picture, the moon would have loomed so large that annular rings did not exist. Eclipses were total by default. Run forward, and the rings take over completely. And then there are no total eclipses at all, ever again. So look where that face has gone. It started as a freak, an anomaly, a thing too big to be there. Then it was a wound, the cooled scar of the worst day Earth ever had. Then it was a casting of our own body, made of us. Then a frozen face turned to watch us. And now, at the end, it's a lantern. A lantern being carried out of the room by a guest who is leaving. Not gone. Not yet. Still here, still bright enough to read by, still hanging up there right now at nearly the right size to hide the sun. But on its way to the door, we happen to be alive in the one brief chapter out of the whole 4.5 billion year story when the lantern still fits the shadow. The people before us saw a slightly bigger moon. The people long after us will see one too small for the trick. We got here while the trick still works. So let me bring you all the way back down, from the violence and the deep time and the lasers to the simplest thing, which is where we started, that gray face in the sky. The next time you see it, full and bright over a roof, or a thin silver paring at dawn, or a half disk hanging in a blue afternoon sky where it has no business being, the plain gray face will have all this folded inside it. The impact, the vaporized rock, the isotope fingerprint that says home. The hidden far side and the flying darkroom. The old theories with their beautiful wrong alibis. The seasons maybe steadied more than we can prove. The tides certainly tugging. The fingernail drift. The eclipse window still open, slowly narrowing. That story used to look like loss to me. Not permanent, not really ours, already going. A near perfect sky that happened to be overhead when we arrived. I don't read it that way anymore. We were not promised any of this. There is no law that says a planet should have a huge moon made of its own body, hung near the right distance to hide its sun. Most planets don't. Venus doesn't. Mars makes do with 2 potatoes. Earth got a catastrophe that cooled into a guardian. And that guardian happens right now, in our brief moment, to be just the right size to make the strangest trick in the sky. We didn't earn that. We didn't build it. We just opened our eyes and found ourselves here, while the lantern is still in the room. The moon will keep leaving. The day will keep lengthening, a millisecond at a time, far too slowly to ever feel. The eclipses will fade out hundreds of millions of years from now, in a sky no one will ever know will stand beneath. But none of that has happened yet. In our brief, lucky moment, the scar is still there, still bright, still ours for a little while longer. A wound from the beginning of the world that turned over 4.5 billion patient years into the gentlest light we have. For the whole length of a human life, it is close enough to perfect. And it is enough to look up, see the same face every human before you saw, and know it for what it is. Not a fixture, not forever, but a piece of home in the dark, holding still, keeping watch, lit just for now.